Howdy hackers, and welcome to another episode of FairLight TV. This is the second part of the little mini-series where we are diving into the hidden secrets of the machine code monitor in Vice, the emulator. So the basics we covered in the first episodes, and basically breakpoints would be sort of the key of episode 3. So the missing parts that we will go through this time would be around storage and other I/O. Playback files, the ability to kind of automate functions. So if you are sort of repeating a command sequence, then playback files is what you're looking for. And also the opportunity of log files that was introduced not that long ago. So if you sit with an older version or one of the previous builds of Vice, then I would encourage you to try to update. We can also have a little session potentially on building Vice, even if that's not really that difficult. But you do want log files. If you have seen the power of logging, especially in combination with playback files, and then also the breakpoints systems that we will go through in episode 3, then you would understand the full potential that this monitor has. But let's not start by talking about what we are going to talk about. Let's dive in. Okay, storage. Attach. Did I spell that wrong? No. Help. Attach. Okay. So this is what you do here is you attach that file to that device. So if you want to attach this D64 file to device 8, I never use the command. I always use it using the GUI, but you can do it from the monitor if you want to. And of course, the corresponding command here is detach. So again, also something I use the GUI for. So if you want to let go of a mounted device, that's how you do that. Help auto start. Okay, so auto start is starting an image and then a file index inside of that image. So if you auto start this D64 and you want file number 4 to run, that's how you want to do that. Again, this is something I do using the GUI, or I mount the D64 using the GUI, and then I just do it using Action Replay. I launch it from inside the emulated environment. I launch the particular file, but it's there as a command, and if you find good use for it, then just go for it. It's there. This so the alpha sign here, it's something which you can use for issuing this command to the C64 disk drive. There is a bit of an issue with this because when you're inside the machine or inside the machine code monitor, you really can't use this properly, because if you're using true drive emulation, this I'll take that back. So what this one is doing is sending the command to the disk drive. But if you're running in true drive emulation and you're inside the monitor, true drive emulation isn't running because it's frozen, because you're inside the monitor. So to be honest, I don't really understand how you're supposed to do this if you're using true drive emulation. And I just had a recent discussion with Gröpas, who's one of the key maintainer of Vice. I need to learn more about this, because what I do is I do this. I enter. What was that? Why did it enter there? Okay, so I do this. I do it from inside the emulated environment because that's when it works properly, always. Yeah, sorry about that. Okay, so that was the alpha command for issuing stuff. Yeah, well, one of the things I tried to do was doing alpha s colon and then the file name for scratching a file name inside the D64, and it wouldn't work for me inside here. I needed to go out into the emulated C64 to scratch that file. And yeah, so let's just admit that this command has serious restrictions because it's actually sending the command to the disk drive. It's not sort of mimicking what the command would do. Okay, L for load. So you're loading a file. S for saving a file. V for verifying a file. You rarely need to verify a file if you're saving it to the PC. It's highly unlikely that it fails if you're saving it to the PC, but if you're saving it to D64, yeah, that's also highly unlikely to fail in the native environment because there are no physical flaws on the D64 image, as there could be on physical disks. So yeah, and I already referenced the fact that when you do this, let's say save file prg 00 means saving it, or 0 means saving it to the native PC system, and then 1000 to FFF. So in the action replay, you would do save file as this, and you would do 1000 to 2000, but here you would do it to 1FFF because it's inclusive of the last pilots you're specifying here. So now I'm saving a file here. Bload, bsave, and bverify is loading and saving without that address, the 2-byte load address. I guess it's binary load, binary save, and binary verify. I'm not really sure about that, but so these are load, save, verify, including bload, bsave, and bverify. And then you have dump. That's basically saving the entire memory or doing a physical dump. If you use the GUI, there is something called snapshot. This is the same. It's saving a snapshot using the same method, and when you save something here using a dump, you can load it using a snapshot, and vice versa. The opposite command is undump, like that. That's loading back a dump. Okay, block read and block write. Block read, let's see, 1201. Okay, yeah. And I wasn't even sure if you enter this decimal or hexadecimal. I tend not to use this command either, even if it's there. I used it a lot on the C64 because that was the convenient way of accessing the physical disk. So what I did here was block read. I'm reading 256 bytes from the sector, from the track 12 sector 01. So this is the first directory sector, and if you do it like this, it will print it. You can also do like this. So you do a block read to a particular place in memory. And this command would give you that sector into the C64 native RAM. But if I do that, it will overwrite part of the intro now, so I'm not using that. And of course, if you want to do block write, you need to have some sort of memory to save to save to that block. So you need to specify an address for that. All right, so and traversing the actual file system in the native machine, and I guess native here means the PC. So you can do CD for changing directory. So if I change to the D drive and then CD to temp, see if there is something there. Oh yeah, there is a file called a.prg, which is like that. Okay, so One of the things that you might want to do is this is traversing. It's like any shell with any environment. You can just traverse your file system as you want. But what you might want to do is press tab for the completion of a file name and all of that. That is not implemented, and that is, to be honest, super annoying. That's one of the things you really want, especially if you have one of those where the path is really long and you want to navigate to that place. And if you want to do that from the monitor, you have to type every character. Okay, MK directory. This is make directory, and then you have RMD for remove directory. That's RMD. Yes, remove a directory. That was very illustrative of what that command is doing. Okay, and there is also PWD. What do you think that is? Is it password? No, it's showing the current path. Help PWD. Current working directory. I don't know what P means. It shouldn't be short for current, that's for sure. Alright, memory map. There are a number of commands around memory map. Let's see if we can do help here. I might even expand that so you can see it better. Where is that? Memory map is here. So memory map show, memory map save, memory map zap. Okay, show. Isn't it like that? MMSH. Okay. So here you print a list of all the addresses in the C64, whether they have been read or written to since flushing the last memory map generation. Yeah, it's impressive that it's done, but it doesn't really show it to you in a very concrete way. I use C64 debugger for this all the time because that's visually showing you what memory is accessed now in real time. This is a bit too cumbersome to actually work with, if you ask me, but it's there. As said, you can kind of reset it, and you can save it and process it externally. So if you start a routine with this reset, and then you run a routine and you enter the monitor again, and then you save this, then you can see which addresses has been tampered with throughout the process of that routine. So I'm sure there are use cases. It's not really something I use, but it's there. Okay, okay, what was that? Main CPU trace. Wasn't that help? Okay, you need to give a command. Okay, so main CPU underscore trace, a very convenient and brief command for you to remember and type. Basically turns on and off this the generation of the memory map. I assume that is what it's doing. Again, not something I ever used ever. Labels. There is a set of stuff that you can do for labels, so it's all of these. So you can add labels. So basically, if you're disassembling something, it would show you the label that you're given a certain address, not only like a plain vanilla disassembly. If you use Kick Assembler and Sublime, the environment that I try to promote every time I have the opportunity, it's doing this automatically in the background. So when you write something in your editor, you assemble it and you start Vice, you would have the labels there. So this is done in the background, and I'm sure the script is using this. It's just that you don't need to bother because it's taken care of for you without you needing to hassle with it. So that's that. Handling of resources. Yeah, what is that? Let's see what that was. It's also something I never ever used, so I don't even know what the resources are in this context. Now I don't even. Oh yeah, here, load resource, save resource, and that. Yeah, I'm sure that's handy. I have no idea. So let's. If you know what it is, please do tell. That's what the comment field is there for. Okay. Reset. Yeah, that's quite obvious. I don't need to issue that because it will reset the machine. It's like pressing the reset button or jumping to FCE2. Stopwatch. It's the current stopwatch. I would imagine it's the same as the one here. So if you... Okay. Oh, something wrong with the sound. And then we do stopwatch again. And now you can see it went from this to this. Super handy. Again, I'm really sure that that is valid for demo coders if they want to validate how long a certain routine is. If they want to term stuff perfectly, it's of course important to know by the cycle how long a call to a routine took. So I'm not saying that. It's just not for the cracker side to keep track of the stopwatch here. Cart freeze, it's like pressing the freeze button, so it's like reset, but the freeze button rather than the reset button. Okay, this, what is that, tilde? So here, print that. That it's taken that as hexadecimal, and now it's printed it as decimal, hex. Is that oct? Yeah, I guess so. And then printing it as binary as well. So it takes what you've written and print it using all four bases. So if you do something more complex, like 10 plus, you do this. Yes, okay, you can do it like that. Okay, so now it calculated this hex plus binary plus oct and evaluated that, and you have the result here. Also very good. If you, rather than having like a hex counter available, it will give you this as a quick thing. Radix. Okay, yeah. I guess the command shouldn't print an error. It would show you the Radix it's using now. But so Radix is, if you want the machine code monitor here to work in hex, decimal, oct, or binary, this is where you can set it. I couldn't for my life think of where I would want to set it to binary. It would just be weird. It's there, and you can use it, but I couldn't see why somebody would like to change this. But I would argue that you should be able to type Radix here. Oh yeah, did I typed it wrong. Of course, Radix. It was pointing to the end of the command rather than here. So Radix, now it prints it's hexadecimal. So that's what that is. Tape control. That help. Okay, help tape URL like that. So here you can basically press the buttons on the tape deck. So if you do tape control start. Now the tape deck is running. Now I've stopped it again. Okay, yeah. It's also something you might want to be able to use, but you are able to do it from here as well. So if you press here just on the stop button, you can do it here manually, and I guess this would be something I wouldn't want to say, but there are times when a GUI is so much easier than just typing a command. I'm sorry to say, but that's my honest opinion. Okay, X and Q. So X is exiting here. If you do Q, you would exit Vice altogether. And I don't want to do that. So, but that is help Q exit the emulator immediately. Okay, side FX. Okay, to be honest, I'm not really 100% sure, even if I read this, but there are a number of registers within the C64. If you read them, you are actually causing something. What could that be? You are confirming an interrupt by reading what is that? No, you need to read them right. Yeah, well, let's say timers. Probably in one of the CIAs or both the CIAs. If you read, you are also confirming that you've read. And if you want those side effects to be there to happen, or if you just want to do the read, I think this is what the command is doing. I have never used this, and again, I'm sure for the right application this is absolutely vital, but it's never been important for me. Okay, we are soon getting into the breakpoint territory, which is where the really interesting stuff lies, but there are a few additional things that we need to go through first. So record sets up a file or starts recording a file of the commands you type. So if you record my commands, no, you need to have it inside like that. Okay, and then D1000 to and then M, and then you do stop. And then you can do playback, my commands. And now you see that it's issuing the same commands again. So this is basically building some sort of batch. You can define a number of commands that you want to repeat over and over again, and that is inside a file. And you can open this file in any text editor because it's actually the commands, very easy to read. It's absolutely plain text. So you can build this command file offline, and then you can execute it or you playback it. You don't execute it, you playback it. Okay. The other thing is you can do logging. Logging is the log on, and then you do M1000 to 1100, and then you do log off, log name. Isn't it log name? Okay, yeah. Okay, so this is also one of the things where you might want a file name. You wanted the program to respond with the file name. If you just give log name, for me it should return the file name, but it doesn't do that. So what this is doing is log name sets the file name that you are working with, and then logging can start and stop. So what you can do is log on, log off, and log toggle, I think. Yes, that's what you can do. And it's when you start logging, it will not kill the start with a fresh content of the file name. It will still add stuff. So this log file can turn rather big. And there is a way inside the GUI. Sorry. Settings, machine. Is it here? Oh yeah, it's here in the first. Monitor net play. Okay, so this is the history directory, current directory. Yeah, I didn't find it. It's here. So here, host monitor, and this is where the log file is. So here we can we can see here that log my commands. That's oops. That was everything for episode 2 of the mini-series diving into the machine code monitor of Vice. You would have to wait another week to see the full potential being totally revealed to you. You will see the breakpoint system and how you combine that with the playback files and the log files. But again, that is for next week. Thank you so much for joining us this week, and looking forward to seeing you next week. Bye-bye.